Good morning. My name is Khaled B Letaief. I'm currently a chair professor at the Hong Kong University of Science and Technology and immediate past president of the IEEE Communications Society. Today, we will be talking about the exciting topic of 6G and in particular how AI will empower future wireless network. So this is the outline of our talk. We're going to start with some motivation, then we're going to talk about AI, in particular mobile edge AI, and conclude the talk. Well, there is no question that wireless has affected every facet of our lives with profound impact in our society, as well as in major sectors of the world economy, including connected and autonomous systems, brain-computer interfaces, e-health, and so on and so forth. And no question that we are continuing to experience significant growth around the world. More importantly, nowadays we are very excited and living in an exciting timing where we are seeing the implementation and deployment of 5G, whose objective is gonna meet certain uh, exciting services such as massive Internet of Things, enhanced mobile broadband, mission critical control, with significant and stringent requirement that needs to be done, such as low latency of the order of as low as 1 millisecond. So the question is, as 5G is now being developed around the world, uh, is there a need for something else? Well, it is becoming clear that many upcoming applications and services will be requiring a new generation. It is also noted that the International Telecommunication Union predicted that the exponential growth of wireless network will continue beyond 5G, and by 2030, the overall mobile data traffic will reach an incredible 60 zettabytes per year. Such incredible growth, coupled with the period of immersion data intensive applications such as the Internet of Everything, tactile internet, digital twin, smart product, smart society, and smart finance, cannot be supported by 5G wireless network and will require the launch of an advanced new generation 6G by 2030 with many exciting technological advances and integrated connected intelligence. In 6G, therefore, we envision that AI will play a very critical role, and we will see an AI empowered wireless network where communications, computation, and AI technologies will be needed to enable intelligent 6G application. So at the moment, we are already deploying 5G, but then significant efforts around the world has already started in order to envision what 6G is all about, the requirement, and then eventually we're going to evaluate, and we would expect around 2030 to see 6G product. So in this context, compared to 5G, what is 6G? What is going to be special? Well, first of all, we're going to be expecting a much higher speed of the order of 1 terabit per second. We're going to be expecting much higher energy efficiency. We're going to be expecting a much more lower latency compared to 5G. And the key distinguished feature is that we're going to be moving to very high frequency bands, including terahertz bands. The other thing that's going to be exciting is that we're going to have a ubiquitous always-on broadband global network coverage by integrating terrestrial wireless with satellite system. And more importantly, connected intelligence is going to be a key characteristics of 6G, where we're going to witness AI networking hierarchy, machine learning capabilities, and so on and so forth. Now, most of us are familiar with this triangle where we can see that there are three major services for 5G: eMBB, low latency as machine type communication. Well, 6G we envision is going to require support of three new services. The first one is what I call COC, and that is going to be important because it's going to be allowing us to have distributed computations as well as the flexibility to choose an operating point in the rate latency reliability space. The second one is going to be CAEC, and this is important because it's going to allow us to be more agile, more adaptive to the network context, to the physical environment context, and to the social network context. And finally, we're going to have something what I call event-defined URLLC, and this is needed to support low latency in extreme and emergency events with spatially and temporally changing device densities, traffic patterns, and so on and so forth. So what we will see that 6G is going to be transformative and is going to be substantially different from previous generations such as 5G and 4G. So with that in mind, we already are deploying 5G in 2020. We expect 5G to continue to improve, and we're going to have an enhancement around maybe 2025. And then finally, we're going to be seeing 6G around 2030. And one thing that is very important I would like to mention is this idea of intelligence level that's going to get better and better and larger as we move towards 6G. So most of the stuff that I just talked about are explained in much more detail in this paper that we have published in the Communication magazine in August 2019. In a nutshell, the magazine talks about the AI-empowered architecture for 6G and talks about the idea of using intelligent radio and how the protocols they're going to be managed, characterized by machine learning. So whatever we're going to look at, whether it's at the different layers of the protocol, whether it's the software, the hardware, we're going to see a lot of co-design between hardware and software, and we're going to see a lot of exciting application and services as well as challenges from a technology perspective. What's interesting is that 6G is going to allow us to have what I call integrated intelligence, and it's going to be able to move us from connected things that characterize 5G to connected intelligence, and that's going to be the key driver for 6G, and will allow us, the whole network, to provide greater level, for instance, of automation, adaptation, etc., etc. So when I look at AI, I see that AI has many issues. There are many challenges, including the model size, including speeds, the energy, for example, the total cost of ownership, or TCO, is becoming very critical. The amount of memory, as well as the privacy, is becoming critical issues for AI. So as a potential solution, we envision that mobile edge AI could be the right way to, and the solution for paving the last mile of AI. Specifically, once we start talking about edge AI, we will see that we're going to be able to somehow move on from channel theory, which aims at maximizing the channel spectral and energy efficiency, and we are moving or witnessing a paradigm shift towards learning communication co-design, or perhaps communication efficient edge AI, where the key is to maximize the training and inference speed and accuracy. So in this context, I would like to emphasize that there is a huge difference between edge AI and communication in the cloud. And it is critical to emphasize that edge AI is far from the trivial task of simply adopting the same computation and communication techniques in the cloud. There are many challenges, especially at the algorithm level. balanced non-IID distributed data set, complicated underlying model structures, plenty of things. At the algorithm level, there exists communication rounds of training a model along with computation overhead per round. The communication rounds can be reduced by accelerating the conversions, while the communication overhead per round can be reduced by information compression techniques. For example, you can use sparsification, you can use quantization. There are different types of edge AI algorithm, including the zeroth order, the first order, the second order, and federated optimization algorithm. For example, in the context of reinforcement learning, the model-free Bayes method turned the reinforcement learning problem into zeroth order optimization. And what we will see that there is somehow a trade-off between communication rounds and the computational cost. This trade-off between these two parameters is now very critical in designing algorithms, and that needs to be taken into consideration for the design of efficient algorithm for edge AI. Now, when I look at the edge AI training in particular, the goal would be for the fast and accurate intelligent distillation at edge from distributed data set. And in this context, I can think of two modes, either distributed or decentralized mode. So the challenge is the limited and heterogeneous resources across edge nodes. And of course, privacy and security is going to be a key issue. So what's the solution? What's the problem? Well, the solution is to do a joint design of distributed learning and wireless networking techniques. So this leads us to something very important, namely federated learning, which is somehow trying to solve the traditional problem of machine learning, where now privacy is a big issue if you want to do it centralized, where also the computational cost is going to be tremendous. So federated learning is a big thing. It's a new distributed AI paradigm where basically the training process is distributed among many, many users. Okay? And the key advantages of this is going to allow us low latencies, a reliable distributed machine learning, as well as preserve the privacy, which is a key issue, as I stated. So there are many ways of how to do federated learning, or what I call intelligence at the network edge. Well, the first one is that you can have a client pool, and you can do the federated learning at the cloud, where basically the cloud is going to be the parameter server where I have a big model to train, but then I'm going to try to do this at the mobiles, for example, or devices where only the parameters are transmitted to the devices where I can do local training at the devices. The other one is a little bit different, where I can use the edge as the parameter server where I can do the aggregation and the training of the model. We believe both of these have serious issues in terms of communication rounds and the training speed and so on. So we have recently proposed, and we have a paper in ICC 2020, talk about hierarchical federated learning, where the idea is to combine edge-based federated learning with cloud-based federated learning, and do it in such a way that you have two types of aggregation, one at the edge, one at the cloud, and we have demonstrated that this is much, much better than the two traditional approaches. Now, moving forward, to think about what type of technologies perhaps we can do in order to promote edge AI, I want to take back and look into the throughput per square kilometer. This is a nice equation that we can look at, and we can see if I want to improve my performance, one way to do that is to provide better spectral efficiency. And in this case, we can use, for instance, massive MIMO system using RIS. The other options, we can use a higher network density. So this is ultra dense network and the integration between space, ground, network. And the other option is simply use more spectrum. For example, that's why we're moving to terahertz communication. So the combination of all of these can give you a much better performance and will allow us to meet the requirement of 6G. In this context, I'm only going to concentrate on the use of RIS because reconfigurable intelligent surfaces can be combined with edge AI. And in this context, these RIS are different elements of an IRS can reflect incident signal by controlling the amplitude and or phase for directional signal enhancement or nulling. So what is so special about this RIS is that there will be no active transmit modules and they can operate in full duplex operation. So RIS empowered edge AI seems to be a great system where we can improve the coverage rate for model training as well as improve the energy efficiency for model inference. We also envision that RIS can be combined with federated learning, with the objective being the construction of controllable wireless environments to boost the received signal power for the fast model aggregation and federated learning. As you can see, remember what we're talking about in federated learning, we have a large model that we would like to train, but then instead of doing it in a centralized fashion, we move on into training it at different levels among multiple devices such as mobile phones and IoT devices. So here we can, by using RIS, we can overcome the unfavorable signal propagation conditions, and we will be able to do a joint design for air computation of the transceivers as well as the RIS phase shift that can be optimized through optimization method. So that led us to how can we optimize edge AI system? Well, it turns out this is an extremely difficult problem because they are mixed integer nonlinear programming problems and they are NP hard. So to solve that problem, we propose, and there is to use machine learning as a way to obtain near optimal solution at affordable times. So recently we came up with something very, very interesting, very exciting, which is how we can use machine learning for large-scale optimization. And the idea that we came up with is something we call learn to optimize for resource optimization by relying on something called imitation learning, which tries to learn the pruning policy in the branch and bound, which is an exact tree search algorithm which would give you a global and optimal solution for mixed integer nonlinear programming problem. So this is a new design paradigm where we allow the machine learning to learn the optimal pruning policy in the branch and bound, and by doing so, we will be able to achieve near optimal performance, and the most important thing, with very few training samples, we can guarantee the feasibility of the constraint, which is difficult in many other ways, machine learning, without performing loss. We can allow very fast conversions, as well as, which is important for real-time application, and finally, it's very critical, it's scalable because it allows us, when the network size changes, when the channel condition changes, and the system, for example, becomes bigger, then this method is amenable and is scalable, and this is very critical. So these are some of the papers that we have recently had, with the latest being our paper in the transaction on wireless that appeared in January 2020. That will give you more details about how we can use machine learning in this context. So, in conclusion, we are living in a very exciting time. We are deploying 5G, but by 2030, we're going to have 6G, which is going to be very important because it will allow us to bring the physical world and the cyber world together. And 6G, without any question, is going to be the platform for the digital society. And there's so much exciting technological innovation that need to be done in order to make this a reality. Thank you. so much.